Alright, so hello everyone. What if an AI could redesign how it thinks while it's solving your problem? Meet Ornith 1.0. Ornith 1.0, self-improving open source models for agentic coding. Ornith is a family of MIT licensed LLMs from deep rainforest that jointly learn to solve coding tasks and build their own scaffold. From 9 billion edge deployable to 397 billion, rivaling Claude Opus 4.7, it runs locally with VLLM, Ollama, or LM Studio. Let me show you why it changes everything. Every other AI fixed pattern. A human designs the workflow, the AI follows it every single time. But Ornith, it designs its own workflow. What's this? It tried a simple fix failed. So it redesigned its approach, tried again, 85% success automatically. This is called self-scaffolding, and it's the first time anyone's done it. It's a two-stage learning process. Stage 1, scaffold refinement, where task and the previous scaffold is given, and stage 2, solution generation. Here, the task and the new scaffold that has been generated from the stage 1 is used. First stage proposes improved orchestration, and second stage executes with optimized strategy. And here the reward propagates to both stages. The model learns not just to generate better solutions, but to author the orchestration that elicits them. Overtraining scaffolds evolve toward higher reward trajectories. Was the self-improvement loop? Here you can see that in first run scaffold A result is 60%, and in second run scaffold B is refined and the accuracy lift to 75%, and finally in third run, that is optimized scaffold, result obtained is 85%. Now coming to the numbers, in the terminal bench 2.1, Ornith 1.0 with 397 billion flagship model scores on the top with 77.5%. It is 10% increment to the Claude Opus 4.7. And the next is SWE Bench Verified, where it is generally used to measure the coding skills. It scores 82.4, and here also it beats all open source models, also paid one Claude Opus 1.0, Opus 4.7. And same, it has got the amazing digits in SWE Bench Pro, NL2 Repo, Claw Eval average. Hence, it is highly recommended with 35 billion parameters. Why? Because it beats 397 billion model despite being 10x smaller. You can see here, Ornith 35 billion score is 64.2, but 23.5 397 billion parameter scores 53.5. The 35 billion model beats a 397 model on a terminal bench 2.1, that's 11x fewer parameters with better performance. Now let's look at how it works on the edge device. So for the edge device, that is on laptop, we use 9 billion parameter, and it matches the accuracy of 31 billion parameter models. So you can see the comparison in terminal bench 2.1 or the 9 billion scores higher than Gemma 4, Google Gemma 4 31 billion parameter, that is 43.1, and same in case of SW bench verified also, it has huge margin of 20 scores. Ornith 9 billion has got 69.4 and Zama 431 billion scores 52. So it is also best for the S device with fewer parameters. Now coming to the model variants, how many models are available for this open source model? So it has basically four model, or you can say four different set of parameters on which it is trained. So for the S devices, we use only 9 billion dense and its size is 6 GB. It runs on laptop with fast inference, offline capable, yes, and using Olama you can run it. And for the balance devices, like little bit of GPU also, if you have with proper RAM of 12 to 16 GB, you can use 31 billion parameter with size 20 GB, and it is perfect for daily coding tasks and also for mid-size project. This also you can import it from using Olama. And finally, the recommended final model is 35 billion parameter. This is best value and it beats 397 billion models of Quen, and but it requires quite heavy setup. You can see here 24 GB GPU plus RAM also, and but it is perfect for professional development complex tasks, and also it is compatible with RTX 3090 and 4090 GPU. And the last one is flagship model, that is 397 billion. This is the SOTA performance. So it means whatever the results you have seen above, the score was taken from this model only, and it's heavy and production ready, and you can use it from the Hugging Face. So this one is the demo, visual demo of the working of this Ornith model. So let's see how it works. So we will run self-scaffolding demo. As you can see here, it is running. It is scanning CI pipeline. Wanted 3 failing tasks. Stage 2 attempting fix. Test still failing. Success is 40%. So it again learn from failure, and it again applies the same test to fix. So success here rise from 40 to 65%, and finally in the third scaffolding, success moved to 95%. So here it basically uses 3-stage scaffolding. So the first one is the initial setup, where simple one-shot tricks with the accuracy 40%. Second one is test first and then error analysis based on the earlier scaffold and the next attempt. Success rose to 65% and finally 95%. So hence iteration required is 18, success rate is 95%, and with scaffold generation is 3. This is quite amazing. Here we can see the comparison with other model, and that too also paid versus open. It performed quite high in every aspect, be it cost, privacy, and other terminal bench scores, licensing. So Ornith wins on performance, cost, privacy, and self-improvement. So you can start using from Ornith. The easiest way is Olama. You can install it and run Ornith using this command in the terminal. And yeah, finally this is it. So you can visit it and start testing it using your Olama and or Hugging Face. It's available open source. So here, why this matters? Every AI you have used, someone else decided how it thinks. Only it decides for itself, and it's giving better at it while you speak. And the link of all the official site, Olama, and full breakdown is in description. Drop a comment. What would you build with a self-improving AI? So here's the solo engineer. More AI breakdowns every week. Hit subscribe to the Solo Engineer YouTube channel if you don't want to miss what's coming next. Thank you.